Today, 10th of July, 2024, Wednesday, 4 p.m., we have this very interesting topic on facade and cladding, the full-scale test of complete facade assembly. Yeah, my name is Dominic from Blue and Gray. We keep posting on various subjects, whether it is electrical, whether it is AI and IoT, and we have been associated with ESL in sharing the knowledge on testing, uh, inspection, and certification. And this is our second knowledge series with ESL, Emirates Safety Lab, we are doing. I'm from the fire background with 34 years in the industry and founding member of many association in India. So most of you know me well, and I just want to introduce today's, as I said, critical aspect of facade and planning testing inspection certification for building, fire, and life safety. As we gather here today, we recognize the vital importance of ensuring the safety and resilience of our buildings. The facade and cladding of a structure play an important role. It's fire safety and overall life safety performance. So today, our speakers will be talking about fire and life safety testing and testing compliances, safety compliances requirement in various regions, testing and classification of standalone product and its importance. So fire testing of exterior wall, cladding and assemblies. So we're going to have a three esteemed speaker, and also we have a keynote by Mrinal who will guide us through the latest advancement, regulatory requirements, best practices in facade and cladding safety. So I request all the audience who have been, who's participating today, ask question. You have a Q&A box down when you if you're watching on a mobile, down menu bar you'll find Q&A. You can post your question. Those who are on the laptop or on a computer, so it's easy to put a question, Q&A, and we will take up, and these questions should be relevant to today's topic, and maybe we'll take up your questions, and if we have very less question. Perhaps those who would like to interact directly on the call, we'll allow you can raise your hand. We'll allow you to join on the call. So thanks once again. I would request everyone to be attentive, take maximum advantage of it. And I would like to introduce today's speaker. We have Julius here from Dubai. So he is based out of Dubai, and he'll be talking to us from Dubai. He's a senior certificate specialist with over 4 years experience in conformity assessment body and has 15 years experience in the field of building engineering and construction. He worked as an electrical engineer and senior MEP engineer with different organizations, delivering wide varieties of small and large-scale building projects, and was involved in building MEP system design, implementation, supervision. So before joining Emirates Safety Lab as a specialist in conformity certification of fire and life safety, he worked in Dubai Civil Defense. COD, approved engineer or inspector in a third-party fire consultant house of expertise, where he enhanced his knowledge and expertise in the building, fire, and life safety. So this is Julius for you gentlemen, and we have another speaker, Rachel. Rachel also worked in the testing inspection certificate industry for over 8 years, and she's a technical expertise in depth knowledge in various reaction to fire standards, including Stenier tunnel test methods, European standard EN 13501 for classification of construction product, roof, fabric, upholstery testing, and cone calorimeter. So that's Rachel for you. And the third speaker, we have Gina. Gina, again, is a fire testing engineer, more than 13 years of experience, specialized in various aspects of fire and life safety, including passive fire protection, testing, commissioning, and fire and life safety design in facade fire testing. So she's been with Emirate Safety Lab for some year, and these three wonderful expertise will be sharing with us today. I now welcome Mrinal, who's a regional manager who also responsible in India, to give opening remarks, and later Julius will come and take on to the presentation. Over to you, Mrinal.
Thank you, Dominic. Welcome, everybody. It's my pleasure to welcome all of you for joining for this insightful webinar on external facades and cladding. As the construction industry is evolving with latest standards, innovations, and best practices in building facade systems, through this webinar, it's our humble attempt to share insights on the latest testing methodologies and certifications crucial for ensuring the durability and the safety of using such systems on the construction projects. I will just brief about what ESL is and who we are. ESL is an internationally accredited third-party testing laboratory and certification body based out of Dubai. We specialize in the fire safety of construction products and building materials. ESL is part of Dubai Civil Defense, and we are capable to test for more than 110 standards and to certify for more than 600 standards. For our guests who are based in different countries and are looking to market their products here in Middle East or in UAE, we are here for the long term to facilitate market access to local, regional, and global entities by providing conformity assessment activities and ensuring safety and compliance with the local rules and regulations. So, although Dominic has already introduced the speakers, but I'm accompanied by my three colleagues here, who he has already introduced. So I will not go dwell too much into that, but they are our subject matter experts who will be sharing their expertise on understanding the exterior wall cladding systems, what are and life safety testing compliances pertaining to these systems, and safety compliance requirements in various regions, not only in UAE but in across GCC and Asian subcontinent. And we will also be talking about testing and classification of standalone products and its importance, and fire testing of exterior wall cladding assemblies. So, without much ado, I hand it over to Julius, who will kickstart an engaging and enlightening session for all of you. And in case you have any questions you want to ask our experts or to myself, please raise your hands, and we will make every attempt to answer them during the presentation. Or if you're not able to do that, we can take them during the Q&A session. Thank you very much, and please enjoy your session.
Thank you once again, Dominic and Marinal, for the warm introduction. And good afternoon to all our attendees. I think we have crossed more than 100 attendees now, and that's so interesting. We are grateful to be with you in this edition of the webinar hosted by Blue and Gray, and we hope that this session will be productive and beneficial to everyone. Once again, I am Julius Sarmiento. I am a Senior Certification Specialist. Our webinar today is divided into several topics related to exterior building facade cladding. I'll be speaking on the introduction, fire and life safety compliances and safety compliances requirements in various regions, and later showcase to you the benefits of product certification. My colleague, Ms. Rachel, will tackle the aspect of standalone testing and classification of products based on the reaction to fire testing. And Ms. Ginalyn will be highlighting the different methods for exterior wall cladding fire testing. So what is an exterior wall facade cladding system? When we talk about facade cladding, it refers to the external appearance of a building. In other words, it is the superficial or outermost part which envelopes the superstructure of the building. Most building exterior design differs from each other. The aesthetic aspect is one of the main reasons why facade cladding is introduced in a building. The cladding system is a non-load bearing element, part of a building exterior, meaning that it has no structural function and is not structurally integral to the building. They are normally supported to the main structure using framing systems mounted on the floor edges and the exterior wall substrate. Besides its main aesthetic purposes, which comes in different colors, types, and styles, the facade cladding system is designed to serve as an external protective layer. It provides weather protection against the effects of thermal heat transfer by improving the thermal conductivity or U value of the building exterior. It also protects the building from the effect of rain, wind, and snow, which contributes to the exterior wall degradation if not properly protected. Facade cladding can be categorized in two types: the ventilated cladding, commonly known as rain screen cladding, and the non-ventilated cladding. Ventilated cladding advantages are that air can move freely inside the cavity, preventing the condensation and accumulation of moisture and allowing water to be drained. However, open joints between the cladding panel present a risk of rapid vertical fire spread, especially when combustible materials are present in the cavity. It also considered the worst case scenario from a fire test point of view. An open state cavity fire barrier must be installed to mitigate the rapid fire propagation in the cavity of a ventilated facade cladding. And then for the non-ventilated cladding like EIFS, there is no air cavity or gap created between the insulation and the cladding or finishing system. Moisture may accumulate over time, leading to the loosening, cracks, mold growths, and frequent moisture repairs. Other non-ventilated cladding may have a void or cavity void between the insulation and the cladding materials. These voids are divided into separate compartments by a closed-state cavity fire barrier system. The joints between cladding panels are closed and sealed using sealant and backing materials and other methods like the dry seal system using an aluminum profile and snap-in silicone gasket. Therefore, it does not allow air to move in the cavity and water from the rain will not penetrate. So normally, exterior wall facade cladding assembly may be composed of the following components: the cladding material itself, which in this example, the cladding is an aluminum composite panel. Then there is a panel gap joint seal system that is applicable to the closed joint type cladding system. Then the supporting frame and wall brackets or the framing system, which can be a combination of steel and aluminum materials. Then the thermal insulation like the non-combustible stone wool insulation materials. Then also we have the cavity fire barrier, which provides the fire resisting capability to limit the fire spread in the interior surface of the cladding. And then the vapor barriers or the water resistive barrier that are used as waterproof or damp proofing. And the primary substrate or the fire resistant straighted exterior wall of the building where the facade cladding system are installed. So here are the various or common types of cladding material used for aesthetic and external weather protection of the building. Let's start with aluminum composite panel or the aluminum composite material. It is made of two thin aluminum sheets bonded to a very limited combustible or fire retardant rated core. It is commonly used cladding material due to its low weight, increased thermal insulation of the core material, durability, and corrosion resistant characteristic. Glass fiber reinforced concrete or GRC is a cladding material that is made of cement, sand, and glass fiber. Glass fiber reinforced plastic or fiber reinforced plastic or FRP is a type of cladding material that is made of combination of glass fiber and polymer resins. EIFS or exterior insulation and finishing system or ETICS are comprised of an on-site installed insulation board applied with a base coat and reinforcing mesh and finishing coating material. Material like terracotta and ceramic porcelain can also be used as cladding material, which is made by firing clay at high temperature. Then we have also sandwich panel or insulated metal panels that are made of two metal skins bonded to a PIR or stone wool core insulation material. Next is the coated solid metals that are made with corrosion resistant, low weight aluminum sheets or stainless sheets that is powder coated or painted with liquid coatings. Then also natural stones like granite or limestones, which are produced directly from the quarry, are also used as cladding materials. And other types like fiber cement boards, high pressure laminate or HPL, and conventional brick cladding can also be used as cladding material. So why fire safety in cladding is very important in buildings, especially the high-rise. When combustible cladding materials and other components are installed in the facade system, the risk of igniting a fire and fire propagation is more likely to happen due to the amount of fire load present in a facade cladding assembly. Similarly, due to the poor fire performance of exterior wall assembly in many buildings, cases of rapid exterior fire spread are being attributed to facade cladding systems. The main causes of rapid fire spread in facade cladding are due to the combustible components, starting from the cladding material itself, then the absence of effective cavity fire barrier that causes the chimney effect and lateral flame spread in the cavity. To address the challenges of facade cladding fire safety, the facade cladding in the existing and new building must be safe and durable. Ensure that the tested and certified materials and systems are used. And lastly, of course, you have to set the highest fire safety requirements and ensure that everyone adheres to the regulation. In this table, we can see how different types of cladding materials are categorized on their fire performance as well as their advantages and disadvantages. Material that do not contain or have less organic content can be classified as having a good or better fire performance. However, it should be noted that when other components with the assembly are combustible, like the insulation, sealant, and other components, even the better cladding material may fail in large-scale fire propagation test. So let's move on the fire safety testing requirements that is that varies in different regions or economies. Testing for facade cladding can be divided into two. First is the testing of material as a standalone product, and second is the testing of the facade system as an assembly. So the purpose of the testing for the product is that it's a determination of material combustibility and materials contribution to the growth of fire. It applies to mostly all the components of the cladding. That includes thermal insulation, vapor barriers, cavity barriers, and group or sealant components. And for the testing of assembly and system, the main purpose is to evaluate the fire propagation characteristic of exterior wall assemblies and also determine the fire performance characteristic of this external cladding system. So here are some of the testing methods that are practiced in different regions. So we have on the right side the reaction to fire testings, or we may say standalone product testing that is applicable for different components of the cladding. But we have to note that these methods does not determine the fire resistance or the product's ability to resist the passage of flame and hot gases. So we have different standards from European, from American, and also we have BS from the UK or something British standards, and as well as also we have IS standard Indian standards that are applicable for testing standalone product. Also on the right side is the testing of assembly and systems that also applicable in different or recognizable in different country, like the NAP 8285 and BS 8414 testing. And again, a note is that this large-scale fire propagation test does not determine the individual components' fire performances and does not determine the fire resistance rating of the system. This table summarizes how different testing compliances are recognized in different regions and countries. We can see that the majority requires that exterior wall facade cladding must be tested as a product and as a system. I will start by giving you detailed information about the requirement for different countries or regions, starting from the UAE. The UAE Parliamentary Code of Practice in Chapter 1 and Section 4, it provides the compliance requirements for facade and exterior wall covering systems that is applicable for a different type of cladding like ACP, EIFS, sandwich panels, GRP, and different type of cladding that are detailed in separate section. So in general, for super high-rise buildings, high-rise building, malls, schools, and hospitals, the cladding materials are required to meet Class A1 or Class A2 S1D0 in accordance with EN 13501. For mid-rise and to low-rise buildings, and also includes warehouse and industrial buildings, the classification required is should be classified to BS1D0 in accordance with EN 13501. Also, in addition to these classifications, some products also require some additional testing like the ASMD 1929 or determination of ignitability of plastic, and also NFPA 268 and ASTM 84 that is applicable for EIFS and ethics. Other components such as thermal insulation, gasket sealant, cavity fire barriers, and vapor barriers are also required to be tested as a product. So also in in the Chapter 1, Section 4, the requirement for testing of all the facade cladding must be done or must be part tested as an assembly and obtain a pass classification in accordance with NFPA 285 or BS 8414 Part 1 or Part 2 under the classification of BR 135. So also the requirement for the UAE is that all the products and assembly system must be tested and certified. And also there will be a requirement that there should be a testing and certification by a UAE Civil Defense approved listed testing and certification body, and to obtain an approval and listing by the local civil defense. So next is for the Kingdom of Saudi Arabia, or which is following the code requirements as per the SBC 201. So in Chapter 1 of SBC 201, it requires that for the buildings type 1, type 2, type 3, or type 4 construction that are greater than 12 meters in height, it should be test and with acceptance criteria of NFPA 285. And for combustible exterior wall coverings that are installed in exterior walls having fire separation of 1.5 or less, shall not exhibit sustained flaming as defined in NFPA 285. So they have also separate requirement for a specific cladding material like the MCM or ACP. So the requirement for the type 1 to type 4 construction, the ACP shall have a flame spread of not more than 25 and smoke development of 450 or less when tested to ASTM E84 or UL723. And also the thermal barrier or insulation materials should also pass the test to NFPA 285, NFPA 275. And also they require that there should be a full-scale testing for the whole assembly that are using MCM system or MCM cladding material based on NFPA 285 testing. However, there's also exception for MCM installation above 12 meter, 15 meter, and 23 meter that doesn't require ASTM 84 and then NFPA 285 test, but they have to satisfy the requirement for fire separation distances and a specific result from ASCMD 1929 and or ASCMD 635. And also the specific requirement for EIFS, it should have a performance characteristic required in ASTM E2568, which is actually a standard specification for PB or polymer-based exterior insulation and finishing system. So the requirement there is that the system has to have a fire performance passing the ASTM E119, NAPA 285, and NAPA 268. And also there's a separate requirement for fire performance of the individual components of EIFS, that they should obtain flame spread of 25 or less and smoke develop of 450 or less according to ASTM E84. Also, there's a separate requirement for the high pressure laminate panels that also installed to type 1, type 2, type 3 building. And similarly, they also require the same requirement for ASTM E84 to pass the flame spread index and smoke develop index based on the required results and test. So in Saudi Arabia also there is a specific requirement for aluminum composite panel for external cladding and internal finish based on SASO 2752. In SASO 2752, the ACP are actually classified in 3 different classifications. The FR1 ACP, which is equivalent to A1, and then FR2 ACP equivalent to A2S1D0, FR3 ACP, which is equivalent to Class B S1D0 based on EN 13501-1. So the only addition here, or as required by SASO 2752, is that ACP should be tested not only to EN 13501-1, but also tested to ASTM E84 to obtain the classification. And basically, all imported or manufactured locally products must obtain product certificate of conformity issued by SASO or its accepted certification body. So we go to the requirement for England regarding facade system on high-rise buildings. So the reference is the approved document B, which is the latest version is the 2022 version, or say the amendments, amendment 2022. So they require that combustibility of external walls should meet the following provision for the external surfaces, materials and products, cavity fire barriers, and also it has to meet the fire performance criteria given in BRE for external walls using full-scale test data from the BS 8414-1 or BS 8414-2. And also in England, since June 2022, the amendment to the approved document B requires that for relevant building or those buildings that contains one or more dwellings, an institution, or a room for residential purposes with height more than 18 meters above ground level, and residential purposes group 1 and 2 with height more than 11 meters that are also become the part of the external wall shall have a classification to A2 S1D0 or Class A1, and for 11 meters or less, Class B S3 D2 or better is acceptable. And for the assembly and recreation buildings, they also require that it should have a classification of the material should have a classification as BS3D2 or better. And for Class C3D2 is permitted for ground level to 18 meter. And for 18 meter or less, with less than 1 meter from the relevant boundary, Class BS3D2 or better is permitted. So for any other building more than 18 meters, all material must achieve Class BS3, D2 or better. And for having less than 1 meter or more from relevant boundary. And also for 18 meter or less building, the Class BS3D2 or better is permitted for any other building more than 18 meter. there are also a certain specific requirement in approved document B for cavity and cavity barriers, and it is written in section 9 that it requires the cavity barriers to have a minimum of at least 30 minutes integrity or E30 and 15 minutes insulation or I15, and the surface which facade in cavity should the provision of the table 12.1 for all materials of external should be complied. So also the requirement in England and the UK is normally requires that product and assembly testing must be tested and certified by an accredited testing and certification body. So moving on to the Singapore code requirements for external wall assemblies or wall finishes. They require that for homogeneous cladding on external walls, it shall be constructed of material of at least limited combustibility tested in accordance with BS 476 Part 11 or approved equivalent. And they also allow Class 0 flame spread rating tested in accordance with BS 476 and 7, and class or also Class B rating classified under EN 13501-1. So there's also separate requirement for composite panels used as a cladding on the external wall, and that it requires that the composite panel used for external cladding shall be mounted against 1 hour fire rated and shall comply with any of the following. So the core of the core material of a composite panel should have obtained or passed the test for BS 476 Part 4, then BS 476 Part 11, and also obtain a Class 0 flame spread rating when tested to BS 476 Part 6 and 7, or to have a Class B or better classified under EN 13501-1. And of course, Singapore also follow that the panel assembly or the exterior wall facade cladding assembly shall comply with NEPA 285 testing requirement. Next, moving on is the requirement from IBC 2001, which is basically applicable for majority of the states in the USA. So basically, the main requirement for the exterior walls are written or provided in the Chapter 14 exterior walls. So here, there's requirements for water-resistive barriers that those that are installed or provided in Type 1, Type 2, Type 3, Type 4 construction that are greater than 40 feet or 12 meters and contain a combustible water-resistive barrier, they should comply with the acceptance criteria of NEPA 285. And for the combustible material on the exterior side of the exterior wall, they require that combustible exterior wall covering shall not exceed 10% of an exterior wall surface area where the fire separation distance is 5 feet. Also, the combustible exterior wall covering shall be limited to 40 feet or 12 meters in height above grade plane. And they also require that wood veneer shall comply with a specific requirement with section 1404.5. So their non-combustible materials in IBC is determined by testing to ASTM E136 and also to ASTM E2652. So there's also an exception for the materials to be not tested to ASTM E136 if the materials having a structural base of non-combustible material is determined with ASTM E136. So these are like, for example, materials that are applied to a non-combustible material like fiber cement board. It will be exempted for the testing for ASTM E84, ASTM E136, and it will be classified as the non-combustible when the surface of not more than 0.125 inch thickness having a flame spread not greater than 50 when tested in accordance with ASTM E84. So there's a specific requirement for metal composite materials, or the ACP. So they require that there should be a fire resistance rating when tested, when the MCM system is used in the exterior wall, required to have a fire resistance rating in accordance with section 705. There's an exemption also to not to test to fire resistance when the MCM system that are part of an exterior wall assembly or envelope is not containing foam plastic insulation. So for metal composite panels, there's a minimum requirement that it should be tested to ASTM E84 and obtain the flame spread index of not more than 25 and smoke develop index of not more than 450. And of course, they require also a separate test of the MCM system to a full-scale test based on NEPA 285 testing. And for the EIFS, the separate requirement from IBC is that the performance characteristic should follow or pass the ASTM E2568, which actually requires this test that is mentioned in the table on the right, that it should be tested to ASTM E119, to NEPA 285, and also to NEPA 268. And the fire performance test of EIFS per component should be tested to E84 or ASTM E84. They have also a separate requirement for the high pressure decorative exterior grade compact laminates, or HPL. So similarly to the EIFS, they require a separate fire resistance rating or fire resistance testing when the HPL is applied on an exterior wall. But they also provide exception that the HPL system not containing foam plastic can be exempted from testing to fire resistance. And similarly, they require that the surface burning characteristic that applies to type 1, type 2, type 3 construction, they have to have a flame spread index of 75 or less. So this is quite lower requirement than the EIFS. So this is 75 or less. And the smoke develop index of 450 or less from the ASTM E84 test. And similarly, they require a full scale test or the fire propagation test according to NEPA 285 for it to be classified as passing the full scale test. So I'm going to that part of requirement in the National Building Code of India. So those part of the Volume 1, Part 4, which is mentioned in Section 3.4.11, although it's mentioned as surface interior finishes, it includes facade, the material that are including in the facade of the building. So here, the requirement for the material for different type of finishes is mentioned to either to be class 1, class 2, class 3, or class 4 based on classes as per IS 1277 standard, where the class 1 can be used in any situation. However, what I have noticed here in the part of the table is that it should be at least provide some specific end-use application that maybe can include the facade cladding or the finishes in the facade. So I'm moving on to the next is about the requirement in the IS standard IS 17682 for aluminum composite panel. So based on the IS standard, the ACP are or can be classified in different grades from grade 1, grade 2, grade 2S, grade 3, grade 4, and grade 5. So what we can see from the table, that the fire retardant requirements of ACP for for specific use for grade 5, you can see that grade 5 is for mineral coal fire retardant for high-rise and special buildings. So grade 5 are the most specific requirement for the external or say external part of the building that are required to satisfy the requirements of these classes. So I have done some checking on some specific standard that is mentioned in this specification of ACP, where I found that some of those standard are having same concept as the other international standards, like for EN for IS 1350-2, which having the same concept as EN ISO 1716 for bomb calorimeter, and IS 3808, which is identical to BS 476-4 or EN ISO 11A2 for non-combustibility test, and the IS 12777, which is identical to BS 476-6 as 7, which is for the flame spread characteristic. And there's also for IS 15061 for the Annex B that having same concept as EN ISO 11925-2, which is for the ignition or ignition of the product or the material test. So I'll be giving the floor to my colleague Ms. Rachel, who will be discussing related to the testing and classification of standalone products and its importance. Over to you. Okay.
Hello, good afternoon, everyone. I hope everyone can hear me.
Yes.
Okay. I am Rachel from ESL Testing Department, Reaction to Fire. I will be discussing today this topic, testing and classification of standalone products and its importance. So here on this slide, we have the UAE Fire and Life Safety Code of Practice. All materials, components, assemblies, products, and its accessories referred to in this code shall be listed, approved, and registered by the Civil Defense Authority. For this afternoon, we will be focusing on the accepted European standard EN 13501-1 test methods and ASTM D1929. For the past years, many significant fire incidents have started with the ignition of products from the walls, ceiling, and floor, as these products are often made of highly combustible synthetic materials. As a result, many lives were lost due to the limited time of evacuation and the dangers that come with flashovers. We always hear the word to prevent flashover. What is a flashover then? Here we have the stages of fire. There are 5 stages in the development of fire. First is the incipient stage. This is where initial ignition happens. Ignition may come from an open flame or smoldering source. The second stage is growth. In this stage, the fire grows depending on the fuel load, combustion type, and oxygen availability. Next is flashover. It is the transitional stage between the growth and fully developed stage. Fourth is the fully developed stage. This is where the fire has reached its maximum potential. Last is the decay. Decay is the final stage of fire. This is where fire begins to subside and no oxygen and fuel is introduced to the space. So focusing on the flashover, it is defined as a rapid fire progress. NFPA 921 defined it as a transitional phase in the development of a compartment fire in which surfaces exposed to thermal radiation reach its ignition temperature, and fire spreads rapidly throughout the space, resulting in full room involvement or total involvement of the compartment or enclosed area. So flashover, in short terms, is a transition from having a fire in that room to having that room on fire. So the UAE Civil Defense, or any authority having jurisdiction of every country, regulates testing for products to verify that every combustible surface exposed to thermal radiation in a compartment or enclosed space does not rapidly and simultaneously ignite and result in a flashover. According to studies by UL, the rate of flashover for modern homes is 8 times faster than it was 50 years ago. So UL determined that fires today are more dangerous and pose more risks than in the past. The findings about modern home fires highlight that the conditions we face today and will face in the future are very different than those faced by prior generations. So in these evolving times, what can be considered as a measurement technique to assess combustibility of materials? This is where the EN 13501 test methods come in. The aim of this European standard is to define a harmonized procedure for the classification of the reaction to fire performance. So this is not a testing standard, but it specifies which tests are to be conducted for which classification and the required results for each class. Let's say for a product to be A2, uh, with no contribution to fire but have potential to produce smoke or flaming droplets, we will need EN ISO 1182 or 1716 in combination with EN 13823. So compliance with EN 13501-1 is often a legal requirement in many countries. By adhering to this standard, you not only enhance safety, but also stay within the bounds of the law. In terms of global acceptance, this standard is recognized internationally, making it easier for companies to trade their products in various markets. So let us start with the first standard. The test is EN ISO 1716, also known as bomb calorimeter test. So it's a fire test that determines the heat of combustion by burning a specimen of specified mass under standardized conditions at a constant volume in an atmosphere of oxygen in a bomb calorimeter calibrated by combustion of certified benzoic acid. So to summarize this quite complicated description, let us watch this short clip about the test. Okay, so each individual component of the product shall be evaluated considering the rules for non-substantial layers. The results relate to the potential maximum amount of energy release of a product when a complete combustion occurs. So we can say here that the higher its calorific value, the more combustible the material is. Next test method is the EN ISO 1182 or the non-combustibility test. So it determines the non-combustibility performance of homogeneous material and substantial components of non-homogeneous products which produce only a very limited amount of heat and flame when exposed to temperatures of approximately 750 degrees Celsius. So we stabilize the furnace at 750 degrees Celsius before we start with the test. A complete test shall be conducted on 5 cylindrical specimens with a diameter of 45 mm and a height of 50 mm. The results relate to the specimen mass loss, occurrence and duration of sustained flaming, and temperature rise in the furnace. Next test method is the EN13823 or the single burning item test. It is an intermediate scale test method to measure heat and smoke release rate, lateral flame spread, and flaming droplets. Heat release rate relates to the amount of energy generated during combustion and placed on the oxygen consumption principle, which shows that the heat release from a burning specimen is directly related to the oxygen consumed during that combustion. For the SBI test, a specimen consisting of 2 vertical wings forming a right-angled corner is exposed to the flames from a burner placed at the bottom of the corner known as the main or the primary burner. The flames are obtained by the combustion of propane gas diffused through that sandbox, giving a heat output of 30 kilowatts. The performance of the test specimen is evaluated over a period of 20 minutes. The results from the EN13823 test relate to the potential contribution of a material or product under intended end-use conditions towards the development of fire. So we have again another short clip showing ESL's SBI test rig. Okay, so that's our SBI test rig. Next test method is EN ISO 11925-2. It is a fire test for determining the ignitability of a product by direct small flame impingement under zero impressed irradiance using vertically oriented test specimens. So the test shall be conducted on specimens with dimensions of 250 mm by 90 mm and thickness not greater than 60 mm. The samples can either be subjected to surface, edge exposure, or both. The results relate to the time the flame front exceeds 150 mm from the application point and ignition of the filter paper below the specimen due to flaming debris. Next is EN ISO 9239-1. So for flooring materials, the SBI won't apply. Instead, we will use EN ISO 9239-1. This is a fire test method for assessing the wind opposed burning behavior and spread of flame of horizontally mounted floorings exposed to a heat flux radiant gradient in a test chamber when ignited with pilot flames. The results relate to the progression of the flame front horizontally along the length of the specimen and the smoke development during the test recorded as the light transmission in the exhaust stock. One of the issues UAE is facing today is the import and export of untested products, say carpets. Carpets are usually tested by consignment only, not in consideration of the carpet's intended and use on site. So ESL, following EN ISO 9239-1 standard, considers that the fire performance should be measured on the total flooring system and not on the carpet alone. It should resemble the end-use application, so it includes underlay, glues, and substrate as appropriate. The last test method is the ASTM D1929. It is a test method that evaluates the flash ignition temperature and spontaneous ignition temperature of plastics in a hot air furnace. This assessment is crucial for comparing the ignition susceptibility of various materials and offers valuable insights into their fire behavior. So this test helps identify the lowest ambient air temperature at which a material ignites. So this provides a benchmark for material selection and application in safety critical environments. In line with the UAE Fire and Life Safety Code of Practice 2018, materials used in exterior facades must meet specific criteria, including a self-ignition temperature of not less than 343 degrees Celsius per D1929 standards. So what do we believe in at ESL? We at ESL believe that modern test equipment using heat release methods as a scientific approach heavily influences the assessment of a material's behavior during a real fire scenario. With our group of experts, we can help you assess the best method to ensure a safer and sustainable future. This ends my presentation on testing and classification of standalone products. Thank you.
So we'll be having Gina Lynn next for the fire testing of exterior wall cladding assemblies. Here, Gina Lynn.
Good afternoon. I'm Ginaline from ESL Testing Department. I'll be covering NFPA 8285, NBS 8414 test method for exterior wall assemblies. Table 1.14 to 1.17 of UAE Fire and Life Safety Code provide an overview of exterior cladding materials featuring options such as metal composite material, aluminum composite panel, and exterior insulation finishing system. This table also includes crucial information like occupancy classification, building type, and other required test standards. Fire testing of exterior wall cladding assemblies. NFPA 285 and BS 8414 serve as a benchmark for assessing the fire performance of exterior wall assemblies. Considering factors such as combustibility, flame spread, and smoke productions. This standard provides a systematic approach to testing the fire resistance of materials and system used in exterior wall construction. helping to identify vulnerabilities and areas for improvement. NFPA 285. This standard provides a test method for determining the fire propagation characteristics of exterior wall assemblies that are constructed using combustible materials or incorporate combustible components. The fire propagation characteristics are determined for post-flashover fires of interior origin. Test facilities and apparatus. The test apparatus shall be located inside the test facilities. The test facility shall protect the test apparatus and specimen for exposure of wind and precipitation. These movable test frames shall be designed such as L angles. So these are the L angles. Meet at the top of the respective floor lines on the test apparatus. Flame source. There are two flame sources used in this standard. One is the room burner and the other one is the window burner. Room burner, in this figure, you can see that the burner is placed inside the first story test room. And another one is the window burner. This is placed near the top of the first story window opening. Test specimen requirements. The test specimen shall be constructed on the front face of the test apparatus or movable test frame. The size of the test specimen shall be not less than 5.3 meter high by 4.1 meter wide. The edges of the test specimen shall be positioned on the test apparatus as per the required distances. Window opening, so this is the window opening, shall be 760 millimeter high by 1,980 millimeters wide with a tolerance of plus or minus 13 millimeters and having the sill height of 760 millimeters above the top of the first story test room slab. Prior to the test specimen shall be cured as required by the manufacturer. If cementitious material or coating, the minimum curing time is 28 days. Test specimen construction detail. The test specimen shall have at least one horizontal joint or seam located between 1 feet and 3 feet above the top of the window opening, and at least one vertical joint or seam extends of the full height from the top of the window opening and be located within 152 millimeters plus or minus of the window opening center line. If these joints locations are used on a tested wall assembly, then any joints location is qualified for the actual wall assembly. There are also exemptions on the joints requirements. First, where the exterior veneer is EIFS. Second, where the exterior veneer is 19 millimeter thick or greater standard stucco veneer. And last, where the actual design of the wall assembly to be used in the field will not have any horizontal or vertical joints. Window opening. The window, header, jamb, and sill shall be closed using aluminum sheet metal. An exemption to the window opening requirements is that the window opening construction used in the test should accurately reflect the construction details provided that the client be installed according to the manufacturer instructions. It is important to note that the window header design, which I have mentioned, was used in a successful NFPA 285 test. Other variation of window perimeters can be used. Some of this variation includes the use of steel or wood of various thicknesses. But a successful NFPA 285 test without including any window perimeter statements, then any type of window perimeter can be used. Test instrumentation details. We will use a type K thermocouple with a gauge 20 for monitoring the temperatures of the specimen and gauge 18 for the burn room. Here you can see the TC location for the front view, interior view, plan view of the burn room. Thermocouple details. Here are the thermocouple details that you can refer to help you decide on the thermocouple positions and quantity to use for each test sample. Calibration requirements. The purpose of this calibration is to establish the gas flow rates required to achieve the temperature and heat flux value prescribed in Table 7.1.11. This standard does allow the tolerance of -10% to an additional 20% degree in Fahrenheit values on the temperature criteria. Calibration instrumentation details. In calibration, the location of thermocouple will be as per these three given figures. Calibration process. The frequency of calibration shall be performed when any of the following occur. Prior to the first wall test, or when significant changes to the gas flow systems are made. For example, flow meters are new. Or within 1 year prior to the test of an actual product wall assembly. And when the ceramic blankets covering more than 50% of the wall or ceiling surface in the burn room are replaced. Also, window burners shall be recalibrated when the ceramic covering the window burner is replaced, or the burner output distribution has been adversely affected by the accumulation of burning or melting debris, causing a change in the flame geometry, or burning output distribution has been adversely affected by the impact of falling debris on the blanket, causing a change in the flame geometry. Performance criteria. The test specimen shall be considered as passing the fire test when the performance criteria specified are met during the 30-minute fire exposure. First, the flames emitting from the surface of the exterior face of the test specimen shall not reach a height of 10 feet or greater above the top of the window opening. Flames emitting from the surface of the exterior face of this specimen shall not reach a horizontal distance of 5 feet or greater from the vertical center line of the window opening. Flame shall not occur in the second-story test room. Flame shall not occur beyond the intersection of the test specimen and the side walls of the test apparatus. And last, the temperature measured by the thermocouple exceeds the maximum temperature set by the standards. Moving on to BS 8414. These standards outlines a test method for assessing the fire performance attributes of non-load-bearing external cladding system affixed to and supported by masonry substrate or structural steel frame. It aims to replicate peak exposure scenario typically associated with external fire source or fully developed fire within a room venting through an opening that exposes the cladding of external flames. The purpose of this test method is to generate benchmark data, facilitating classification of non-load-bearing external cladding system. Test apparatus. The test apparatus shall consist of a masonry wall or vertical structural steel frame, comprising a vertical main test wall and vertical return wall. The main test wall shall be provided with a combustion chamber. Test apparatus requirement. The table outlines that apparatus requirements for BS 8414 Part 1 and 2. The primary distinction between the two is that Part 1 utilizes blocks, while Part 2 utilizes structural steel frame. Main test wall shall have a vertical height extending to 7,700 plus or minus 100 millimeters above the top of combustion chamber, opening and at least 2,600 millimeters wide. While return wall shall be perpendicular to the main wall with a vertical height equals to the main wall and minimum width of 1,500 millimeter. Combustion chamber opening shall have a robust lintel across the head of the chamber opening. We will also use timber heat source. This is softwood sticks or Pinus sylvestris. The timber tree was constructed nominally 1,500 by 1,000 millimeter in plane and 1,000 millimeter in height. Also, 16 strips of low-density fiberboard will be used to soak to a 5 liters of white spirit, not more than 5 minutes before the ignition. After the ignition of the crib, it will be extinguished after 30 minutes. Thermocouples. All thermocouples shall be type K and mineral insulated and have a 1.5 millimeter diameter with insulated junction. This thermocouple shall be positioned on the specimen in both external and internal location at specific distances, as shown in the figure. External thermocouple shall be positioned to a tolerance of plus or minus 10 millimeter, with the hot junction positioned 50 plus or minus 5 millimeter in front of the face of the test specimen. Internal thermocouple shall be positioned at the midpoint of each layer and cavity with a depth greater than or equal to 10 millimeter. Standard requirements. Early test termination line shall be drawn horizontally across the main face and the wing at level 3. The following are the equipment required in the standard. Data acquisition system shall be capable of recording data every 10 seconds interval and connected to the instruments. Audiovisual equipment shall capture the entire height of both external faces and the full duration of the test. It will record the full details of the fire spread and mechanical performance in such detail that full evaluation of the system performance is possible. Anemometer. The air velocity is any direction at level 2 when measured 1 meter away from the center line of the combustion chamber. Opening shall not exceed 2 meters per second. A timing device is also required. Timber crib shall be ignited at least 5 minutes after the data acquisition. Specimen requirement. The test specimen main wall shall have a width of at least 2,400 millimeters and a height of 7,700 millimeters above the combustion chamber with a tolerance of plus or minus 100 millimeter. While the wing wall shall have at least 1,200 millimeter wide and height equals to the main wall. Horizontal joints, if incorporated into the external wall cladding system, one joint shall be placed 2,400 millimeters above the combustion chamber. While vertical joints, if incorporated into the external wall cladding system, at least one joint shall be placed plus or minus 100 millimeter on the center line of combustion chamber. For horizontal and vertical cavity barrier, these shall be located as per end-use design. Moving on to performance criteria and classification method for BS 8414 Part 1 and 2 as outlined in BR 135 Annex A and Annex B. Since there is no pass or fail criteria in BS 8414 Parts 1 and 2, a classification of fire performance was also required to interpret the test data. This classification system formed in Annex A and B. In order for classification to be undertaken, the system must have been tested to full test duration requirements of BS 8414 Part 1 or 2 without any early termination of a full fire load exposure period. Fire spread start time. The start time for fire spread is initiated when the temperature first recorded by any external thermocouples at level 1 equals or exceed 200 degrees Celsius rise above the start temperature for at least 30 seconds. For the external and internal fire spread, the temperature rise above the start temperature of any of the external or internal thermocouples at level 2 exceeds 600 degrees Celsius for a period of 30 seconds within 15 minutes of the start time. For mechanical performance, no failure criteria have been set. So I'll give it to Mr. Julius again.
Thank you, and thank you, Rachel. Thank you for the informative presentation. So I'll be continuing related to the benefits of product certification. So I want to ask to everyone that how do you find certification or product certification, the importance of it? So basically, the importance of the certification is that it provides confidence on the process and as well as on the product or manufacturing of the product that are used in building or building materials, and the consistency of how these products are manufactured and how they are maintained by the manufacturer through a consistent audit by the certification body, and as well as it ensures impartiality during the certification process. The certification process also involves the following steps, which I'm going to discuss in the next slide. And lastly, what are the benefits of product certification? So basically, product certification gives assurance to the end user that the product delivered and installed meets the certain requirements. It also ensures that there's a certification body that watches over certified product manufacturers and check its consistency in producing the tested and certified products or system. And also the traceability is maintained and ensures a level playing field on the level of what do you call on the competition. And it may also as well embark the economies to regulate construction products. So this helps different economies or regulations to ensure that the products and systems that are used for building constructions are complying with international standards and local regulations. So here I'm going to show you how the product certification is done. So first is the application, where a request is received from an applicant, either from a manufacturer or an agent of the product. Then relevant submitted technical documents are reviewed and plan of evaluation is made by the certification body and whoever is doing the product certification process. Before the testing, there will be a sampling of product samples, and this is how certification body ensures that what will be tested will it's checked, and the proper traceability is performed, so it can present the repeatability of the testing that will be conducted in the testing laboratory. So we have also the initial factory audit, which is performed in which the quality management system of the manufacturer is assessed diligently, and also including how the manufacturing process are maintained, in a sense that the quality follows the certain international standard like ISO 9001. And after this testing and factory audit, a decision is made. And of course, if the testing is successful and there is a positive outcome in the audit, a certificate will be issued to the product manufacturer. And this certificate is maintained periodically, evaluated through factory auditing and audit testing as a surveillance measure. In the UAE, tested and certified product system shall be registered and approved by civil defense, meaning every Emirates of UAE requires that the products or systems that are used in their Emirates are registered to the local civil defense. And that goes to our Q&A. So this will be, we are happy to answer your questions that are that you can highlight to us, or maybe there's already questions that are
Thank you, Julius.
listed.
Thank you,
Yes.
Julius,
Thank you.
and everybody for Rachel and Gina for the session. We have a couple of questions. So I will ask those questions on behalf of the which I have received, but I'll let everybody to pitch in for with their questions so that we can answer them right now. The one question I have is, what about FM 4880? Is it accepted by any of the regions that we have discussed?
Well, current code requires yes, it accepts 4880, but basically FM 4880 are tests that is applicable for internal and exterior wall panels, or say materials, and it is also acceptable in the UAE in some particular requirements, in the sense like for the for the qualifying of products as a standalone product. So yeah, FM 4880 contains several test methods that has to be complied with to obtain, or to be accepted as what they call cladding materials.
Okay, fine. There's another question that what about solar panels which are used as facade?
Okay, so when it comes to the UAE Fire Life Safety Code, there is certain requirements that is, if I'm not mistaken, in the chapter 14 of the code, that is specifically mentioning the requirements for solar panel, or to be specific, BIPBs that are used as an external facade cladding, and the requirement there is that they should comply with the requirement of table 1.15.a, if I'm not mistaken, that is for the ACP. So basically, there is no direct specific requirement for the solar panel or BIPB. However, it goes back to the requirement similar to the MCM or ACP for testing as a product and as an assembly.
Oh, okay. And there's another question. EN 13501-1, is this classification applied to all roof system materials for UAE and KSA?
So I'd like to answer this question. For roof system materials here in UAE, we are following EN 13501-5. So this is following Sense 1187 test method for external fire exposure to roofs. So it's not -1, rather -5. Yeah, that's it.
Okay, and same is applicable for KSA, is it?
I believe yes.
Okay.
Okay.
Is there any other question from any of the guests?
In fact, in National Building Code 2016, we have got very limited features. So far, the external envelope and the external cladding is concerned, we have got very limited scope to taste and to verify the type of cladding we are going to provide in various public buildings. You have already spoken it nicely that whenever the people will be evacuated either horizontally or vertically, they have given more importance for the 2-hour fire rated products for internal use. However, for the external use, when the external cladding will be flamed, in the entire inflammation will be taking place at the external cladding itself. So we have got the alternative choices, whatever already we have given the presentation earlier, that we have got the alternative choices. So for hospital projects, which material will choose for the exterior cladding?
number one. Number two, whether we'll go for a ventilated cladding system or we'll go for a this is direct cladding system on the wall. So these are the two things we have to know.
Yeah. Yeah. Let me answer, Marnel, the first question.
Yeah.
I think you have asked that what particular or what should be the required type of cladding that should be installed in hospital
Yes.
setup. I think,
Yes.
yeah, uh, although it's not explicitly mentioned in those codes or different countries' regulations, in the UAE, the specific requirements for this type of, say, occupancy, it requires that the cladding materials should be cladding materials, specifically the cladding panels, or should be at least achieving class A1 or A2 S1D0 classification to EN 13501-1. That's the most say class of material that is applicable for that type of occupancy. And for the next question is, I think the other question is something related to design. So I believe that I'll leave it to the specifier or the consultant to, I mean, to know what is the specific requirement for a different type of buildings. Yes. But of course, it is always advisable to use non-combustible types of cladding materials.
You see, this non-combustible type of materials, it is understood. But the first question is that the client will ask why at all will go for a cladding on a plastered and painted surface. The cladding we are going for to avoid the painting, and it is going to give you a permanent finish on the top of the wall.
Yeah. I think, as I have mentioned earlier, cladding are normally present in buildings because of some specific aesthetic requirements, right? So if buildings that doesn't require such type of systems, or may not require additional exterior weather protection, apart from what is already available exterior wall, then it's not actually necessary. Like, for example, as you said, the plaster and paint finish building, yeah, that should be enough. And it's more reliable in the sense that the external fire spread can be prevented. Yeah.
And when we are talking about the envelope as a assembly together, it is confronting the windows and the glazings and the structural glazings, all these things.
Yeah.
So your presentation didn't speak of anything about that.
So what I understood from your question is when there is some intersecting between a different system and the cladding system, right? You mean to say, like when
Yes.
there's a glazing wall,
Yes.
and
Yes.
then there's yeah. Basically,
Yes.
what I understood in this kind of setup is that when you have a cladding and a glazing, that there's normally glaze or curtain wall are basically suspended or supported from the floors, and when they are intersecting with these materials, the specific requirement to include cavity fire barriers between them or between the cavity should be included. Yeah.
Mr. Dahl, if you,
And one more.
Mr. Dahl,
Sorry.
yeah, sorry, sorry to interrupt, but I would request because we have to. I mean, being considerate of the time here, so we have to allow the questions from the other participants as well. So, if I would request you to drop your questions to us directly. Arya, if you can drop our emails in the chat box so that Mr. Dahl can send us the emails with the specific questions, and we will try our best to answer them.
Okay.
Is that okay with you, Mr. Dahl?
Yeah, yeah.
All right. Thank you. Thank you for your questions. And there is another question from Mr. Dhaval. Mr. Dhaval is asking, is this approval also required in India or not?
When we are constructing a building, correct?
Yeah.
Then there is any role of the cement, which is the medium between two bricks or two concrete or two cement bricks to join that. So, is there any role of cement in the fire cladding or in the fire safety?
As I understand, you're asking what's the role of cement or concrete in the fire
No, no, no. I am
cladding?
asking that is there any role of the cement category in the fire safety or not?
I think what he means to ask is that if the cement which is being used in the construction, does it have a role to play in the fire safety?
Yeah. You're correct.
Okay. Okay, so yeah, moving out, I think from the topic of facade cladding. So yes, of course, cement, or I may say, I put it directly as concrete wall or masonry wall. Yeah, there are certain requirements in different regulations, or yeah, a different country, that there should be a minimum fire resistance requirement for the fire separating elements to maintain the compartmentation of different uh, compartment of the building. Like for example, if you have partition walls or exterior wall, there is a certain requirement how many hour fire rating should be applicable for a specific part of the specific walls or floors, even the floors. Yes. So yeah, the effect of the cement or the effect of a specific material during fire will likely contribute, like for example, the performance itself. Yeah. So I
Okay,
hope
thank you. Thank you, Arthur.
I hope I answered your question, right?
Yeah, you have answered. Okay, but I will search on that more. But I have clear right now.
All
Okay.
right, thank you.
Moving on to the next question. There is a question by Anna, who is asking that ventilated facades, is this considered also as fire rated?
What kind of facade?
Ventilated.
Ventilated facade. Is it fire rated?
Is this considered as fire rated as well?
I think yeah, I think I have mentioned earlier about what is fire resistance. What is the purpose of facade testing as compared to a fire resistance testing? So, putting a fire rating on a ventilated facade actually not included in the specific tests for assembly. Rather, it is how assembly will perform, or what is the characteristic of an exterior wall assembly in a large scale test that involves fire or fully developed fire originating from the interior part of the building. So when we call it fire rated, of course, it will not be called as fire rated, but rather compliance with a specific facade testing like NEPA 285 or BS 8414.
Okay. There are two more questions. One from Mr. Rajendra. Mr. Rajendra, I'm unmuting you, so please you can uh, you can ask your question.
Good evening, all. Can you hear me?
Yes, loud and clear.
Yeah, thank you. My first questions in NFPA they mentioned the facade fire risk assessment. So it is required to conduct the fire risk assessment for the facade for the installation purpose and as well as the confirm the fire rating for the material. Second questions during my building audit, high-rise building audit, that building was above 50 floors. What I observed, there is a gap between the facade and the flooring, so that gap was a 66 to 8 inch, and that gap is generally filling by the our rock wool. Because of this rock is not secured properly by the cladding material, and the housekeeping guy and some other people that removed that rock wools. And I highlighted that this is total unsafe conditions. And when I asked to the people why they removed, they told me this is not secured. So people are when the people are stepping on this rock wool area, this creating unsafe conditions. So how will we control this type of the practice?
Let me answer first the second question, because the first question I will ask you to repeat it. But for the second question, I believe that you're pertaining to a curtain wall system, because you said that it is a floor, then there's an edge, and then there's exterior wall. So basically,
Yes,
the
not
part,
a door, floor and wall. Because this facade material is double wall material. This aluminum cladding material they use.
aluminum cladding material.
Yes.
Okay. And then what is installed in between the wall and the cladding material?
Rock wool.
Rock wool. Because there are two types of what you can see in the cavity. Basically, you will see the thermal insulation, which is actually applied throughout the wall itself. And then there is
Yes.
something called cavity fire barrier system that is
Yes.
that is installed between the wall and the inner face of the cladding. So is this the same information you mean to say?
Yeah, both are. That is a seen in the cladding and internal wall of the
See,
facade material,
yeah,
as well as there is a when the installing the facade, the clamp and everything. There is a gap between the floor and the facade facade wall. So that gap is they filled by the rock wool, but the rock wool not secured because there is no proper material to secure the hold that rock wool weight and all these things. So they remove that rock wools and they created unsafe conditions for the fire also
yeah,
and for people also.
yeah. So I
And then
understand.
another question was how. Yes, go ahead. Go
Yeah,
ahead.
yeah. So I understand. So this is basically the cavity fire barrier. So it should be
Yes.
properly maintained and first properly installed first, and should be maintained, because the main purpose of this specific component is to resist the flame spread that comes, basically the chimney effect, meaning when there's a fire coming from the bottom, it will resist the flame spread in the cavity in some certain
Transfer to
period.
the another area also. Yeah.
Yes, yeah, to prevent the flame or the fire to jump to the other floor, or to the upper.
Yes, yes, that is chances. And that fire risk assessment, there is a fire risk assessment available in the NFPA site. I just refer that the this fire risk assessment for the facade material, but that practice is
NFPA,
no one is
what
this general
NFPA?
not particular NFPA on NFPA site is available that facade fire risk assessment. You will get it. That is near about 35, 40 pages fire risk assessment for the facade materials.
Okay.
So, but when I asked to the many people, it is a required to conduct the fire risk assessment of the facade. But I haven't, I didn't get any satisfactory action from the expert people.
I think
So, what is your opinion?
I think your intuition is, I mean, better to, good, that in the sense that you are looking for a more definitive, definitive and reliable information about how the facade is tested. Yeah.
Yes.
As I mentioned earlier, in the UAE mainly, you cannot evaluate a specific or a different component that will be put together to form a facade assembly, and it will not be acceptable to have such what they call assessment, risk assessment, as you
Yes.
said.
Yes, risk assessment.
Unless there are what they call there are supporting or substantial documents that relates to fire or facade testing. So the requirement is that when you have a different components that are tested to as a product, and it's not proven to pass a test for a fire propagation or facade system or facade testing, it should be tested. But of course, if there's already a system that is tested and there's only acceptable alternatives based on the standard, then that will be acceptable. But if it is not really tested, like for example, a cladding material that is not tested from the earlier part and then assess only that it will pass, no, it is not acceptable in a sense, in majority of the regulation of different country.
Okay. Thank you, Julius. Thank you. Okay.
Thank you, Rajendra.
I hand over to you. Thank you.
All right.
Before we do that, I want to, extend my sincerest thanks for attending our webinar on facades and cladding today. It was a pleasure to have all of you with us, and I hope you found the session informative and valuable. And really, the active participation and the thoughtful questions that were asked, they contributed significantly to the success of this webinar. So our email IDs of our subject matter experts have already been posted in the chat box. So if you still have any more queries or you want to engage with us on any requirement, please feel free to do so. And we will be having more of such webinars in the future. And whenever we do, we will keep you posted about it. And you can also visit our LinkedIn page for more information on different standards applicable for different products and systems, not only in UAE but world over. We keep on posting all the knowledge material, most of the knowledge material on LinkedIn and other social media. So please, you can also visit those pages. And I thank you all. It is, like always, rewarding to engage with such a beautiful audience. So thank you very much for coming in.
Thank you also from our side.
And thank you, Julius. Thank you, Rachel. Thank you, Gina, and thank you, Team Blue and Gray, for arranging this.
Thank you, Mr. Brown. Thank you.
And I look forward to talk to you soon.